how is modern infrastructure impacting application availability at scale?
Yeah, it's very complex, right? We have the infrastructure side. You typically have a compute, storage, network layers, and we have gone away. Earlier, we used to have only physical devices. Now we are able to virtualize all of these layers. Compute we've been virtualizing for a long time. Storage we've been doing that for a while, and network, now we have succeeded in virtualizing as well. So with that, you have a ton of stuff that abstracts out. So it's very hard to put a finger on something and say, hey, it's this router that is a problem, or it's this router that is not doing well anymore. You don't see anything anymore. It's virtual. And secondly, it is also existing in other places where you don't touch it anymore, right?
Mhm.
Earlier you would hold everything in your enterprise data center, but now with the cloud, you are now having a network device or a compute device or a virtual machine or a Kubernetes container, microservice environment sitting somewhere in the cloud, and you have no idea where that is.
Mhm.
So it's on one side, it's the lack of visibility. Second is it is ever moving, it's dynamic on a constant basis, which means you don't know what the exact underlying topology is, even though there is a virtual topology that you can get your hands on, but it changes, and then the what is underneath, you don't have visibility. Number three, the issue is when a problem happens, you need to first know whether the problem is because of sheer increasing demand, right? I mean, you can have
Mhm.
more users. It's a good problem to have, as they say.
Mhm.
Of course, once you have that, you want to increase capacity, and the natural tendency for us and IT ops teams and SREs, site reliability engineers, is to, if your traffic increases three times, you increase everything three times, and that really doesn't solve the problem, right? The choke points are not necessarily uniformly distributed across your infrastructure. It may be that one place needs 10x in capacity, whereas the other place needs only 1.5 times increase in capacity. And some places may not even need increase in capacity.
Mhm.
So just by increasing 3x doesn't solve the problem at all. In fact, your problem just got shifted from one place to another, and then you wonder, I spent three times more money, and I'm still having the same problem.
Mhm.
So it's important to get granularity, visibility at a level that is needed. Second is to tie in, what is coming in and what is expected and what is really happening, right? That's where going back to observability is critical, because when you monitor the CPU utilization or the memory or a network availability and so on, you eliminate the first order problem. You know, if something is constantly more than 95% utilization, you need to increase capacity, you have a problem there.
Mhm.
That's not always the case. You need to tie that infrastructure with the application. In the case of Facebook outage that happened last year, it was an application and the network doing things separately, and it was not visible because the teams that are managing these are two separate teams. So they couldn't tell. As human beings and as the way the teams are structured, they couldn't tell. Whereas if you had let a machine go in and look at and do a correlation, it would have been, it could have been, I'm saying that, it would be possible to say that, hey, there is something funky going on here and we need to do something about it. And it can percolate that up to an IT ops or an AI ops person that can then go in and look at it, especially if it can tell you. In many cases, again, it's like finding a needle in a haystack, right? First of all, you need to know if there's a needle, and then second is you need to know which haystack the needle is in, and then the third is which general smaller region that it's in, so that you can now go in and pick it out. So in many cases, we don't even know there's a needle. All we know is something is poking us, and
Yeah.
we don't know why.